It is the time to start our sessions. It is the second day of faculty development program. We have two sessions today. Technical session 3 by Dr. Srinu G, Assistant Professor and Assistant HOD, Department of Cybersecurity, Muthoot Institute of Technology, Cochin. And she will be talking on the topic Foundations of ML and Deep Learning. And we have another session which will be starting at 7:30 p.m. Till 9 p.m. Technical session 4, hands-on ML and DL using Python. And it will be delivered by Mr. Dilip G. He is the Chief Technology Officer, One Team Solutions Private Limited, Kochi. This is today's business, and we are directly moving to the technical session 3. I invite Dr. Bibina, our head of the Department of Microbiology, Majlis College Autonomous, for delivering the welcome address. Ma'am, please.
Okay. Good evening to one and all. With great pleasure, I welcome you all to the second day of our 6-day faculty development program sponsored by AICTE Training and Learning Academy on empowering educators with the next-gen computing, AI, supercomputing and data science, organized by PG Department of Computer Science and Application, Majlis Arts and Science College. First, I extend my heartfelt welcome to our principal, Dr. Muhammad Kutti, for this session. It's my honor to welcome today's distinguished resource person, Dr. Srinu G, a highly accomplished academician and researcher with over 16 years of experience in engineering education. Dr. Srinu specializes in deep learning, computer vision, cyber security, and computer networks. She holds PhD in deep learning from VIT Vellore. She has been a resource person for FDP on artificial intelligence, machine learning, and deep learning. She currently serving as assistant professor and assistant head at Muthoot Institute of Technology and Science. We are delighted to have you with us today, ma'am, and we extend a warm and respectful welcome. I also welcome all the participants who are joining with us today. I also welcome the Ms. Agila P, Ms. Sharanya, and Ms. Chitira for the technical support. And once again, I welcome one and all to this session. Thank you, and let us begin the session.
Good evening, ma'am. Am I audible?
Yes, ma'am, audible.
Yes, ma'am, we are audible.
Okay. Good evening, all. Once again, thanks for the warm introduction. So I will share my screen now.
Yeah, it's visible, ma'am.
I think it's visible now, right?
Yes, ma'am.
Okay. Shall I start the session now?
Yeah, sure, ma'am.
Okay. So good evening, all. So my topic for today's session is Foundations of ML and DL, Machine Learning and Deep Learning. Myself, Dr. Srinu G. I'm working as Assistant Professor and Assistant HOD in the Department of Cybersecurity at Muthoot Institute of Technology and Science. So let us start the session. So before getting into the details, like what is machine learning and what is deep learning, so I just want to recollect some points. Like you can see in my slide, how does YouTube know which video I will click next? How does Instagram decide which posts appear first? How does an e-commerce site recommend clothing that fits my style? How does Amazon suggest customers who bought this also bought? So these are some of the interesting facts every day we are seeing. So actually these are all AI applications powered by machine learning and deep learning, running on next generation computing infrastructure. So we probably use it several times a day without even realizing it. So we all are using machine learning and deep learning in our everyday life in one way or other. So for my today's session, these are the contents. First of all, an introduction, then the core concepts of machine learning, some advanced insights, then we'll start neural network fundamentals. From neural network fundamentals, we'll move to deep learning concepts. Then if possible, if time permits, we'll see some deep learning advanced architectures. So let us start. So you can see an image in my slide that is from rules to learning, the evolution of machine intelligence. Human write rules versus machine learn patterns. So from here we start. You can see on the left side, human write rules. Second, the right side, machine learn patterns. So in the earlier days of AI, we wondered if you wanted a computer to recognize spam emails, we wrote rules. Like normally in spam mails, suppose sometimes you may get a message like you won the lottery. So that mail contains common words like lottery, winner. So if these words are there, it's sure it's a spam mail. So we can create our own rules. Like if the email contains the word lottery and winner, then mark it as spam. But later on, the emails got creative. You are selected for a reward. Then what happens? Our rules contain only words like lottery and winner. So the system failed because it doesn't contain new terms, new rules. So that is when we realized computers shouldn't just follow rules, they should learn them. See, whatever we write, the computer is a dumb machine, it just follows the rules. But sometimes it is a success, sometimes it is a failure. So we don't want the machine just to follow the rules. It should learn from the rules. So there comes machine learning. So we can see a table here. So you can see from 1980 to 1990, it is a rule-based approach. An example, expert system for medical diagnosis. When it comes to 2000, machine learning starts. 2010, the era of deep learning. So how machines learned to learn. So you can see three sections. We started with rule-based AI, that is expert systems. Then we slowly evolved to machine learning. So now we are using advanced applications of deep learning. So what is rule-based AI? I already gave you an example of spam email. It uses rules like if the condition, then the action. So the problem is sometimes we can't handle uncertainty. Since it's a real world applications, we can't predict this will happen. So the system is not able to handle real world complexity. So it couldn't generalize to unseen diseases like expert system, a medical expert system diagnosed bacterial infections based on rules. So sometimes if something is missing in the rule, it cannot predict what kind of disease will happen. So it couldn't generalize to unseen diseases. So then comes machine learning. The system is learning from the rules. It doesn't follow the rules blindly. It starts learning from the rules. So machine learning is teaching computers to learn from data without being explicitly programmed. We are not giving any algorithm. We just give data. From the data, the machine learns. Just like human being, we are learning from our experience. The same way machine is learning from data. So here, data is the experience. We are not giving any explicit algorithms. We feed the computer with thousands of examples of spam and not spam emails. It's an example. It learns patterns that even humans can't easily describe. The ML model automatically learns what words, styles, or patterns make an email likely to be spam. That is the power of data-driven learning. You can see two examples. One is traditional programming, one is machine learning. We already identified the example. So in traditional programming, it's a rule-based thing. We'll give if condition, then the corresponding action. So when it comes to machine learning, we are not giving such conditions. We just feed the computer with a lot of spam and not spam emails. From that emails, the machine learns what kind of words, what kind of styles, what patterns make an email likely to be spam. We are not specifying this word will generate spam, this word will generate not spam. We are not specifying any rules. We just give a lot of examples of spam and not spam emails. From that, the machine will understand which makes it spam, which makes it not spam. So that is the power of data-driven learning. So this is a best example to explain what is machine learning. A typical machine learning project life cycle. So you have to define the problem. So make sure, I already mentioned you in my previous slide, it is the power of data-driven learning. So if machine wants to learn, it needs that data. So before doing any project, any problem, before solving any problem, make sure enough data is there. So you have to collect the data related to that particular problem. Once the data is collected, apply pre-processing. Once the data is good enough, you can use a model, that is model selection. Then you can start training, then validation, testing, and deployment. So this is a complete machine learning project life cycle. So here, I just want to explain machine learning algorithms using a real world problem. So here I am using an example, that is customer behavior analysis for an e-commerce platform. Customer behavior analysis for an e-commerce platform. So this is my theme. So based on this particular theme, I just want to explain machine learning algorithms. Different machine learning algorithms we are going to see. So as per the life cycle, so this is the machine learning project life cycle. So the problem is defined now. These are the different steps in project life cycle. Now the problem is defined. What is the problem? I have to analyze behavior of a customer in an online platform. So that is my problem. I want to analyze the customer behavior. So that part is over. Problem definition is over. Now, what I need? For that, I need data of customers, right? So that is the second part, data collection. So normally, imagine we are working for an online retail company like Amazon or Flipkart. We have customer data such as age of a customer, gender of a customer, annual income of a customer, the spending score, purchase frequency, browsing behavior, like how much time he is spending on the site, what kind of items he is choosing, product rating. So normally these are the data available. So we have the data. So this kind of data we need. Data collection. So we need this much data. This much features of a data. So you can see an example. Around 5 records you can see. Features are customer ID, age, income, spending score, time. Then the result. Based on all these, whether he purchased or not an item. So the features and whether he purchased or not. So I have a data set now. It's a very small data set having 5 records, 5 rows, and number of fields. Customer ID is a field, age is a field, income is a field, number of field. So now the data is with me. What is the next step as per the life cycle? We defined the problem, we got the data. The next step is pre-processing. So pre-processing. So these are the things we have to make sure while applying pre-processing. To ensure quality, we should inspect the data, we should clean the data. Prevent bias, handling missing values. And if it is text, you have to convert it to numbers. Sometimes scale features, select relevant features, split the data. So these are the pre-processing steps. So data inspection. So before cleaning, we look at data types, missing values, duplicates, outliers. So the data set which I have shown you, the customer data set which I have shown you, there is no missing value. All columns have valid entries. And the purchase, the last column was purchase. That is categorical like yes or no. The rest of the fields are numerical. It's a mixture. My data set, the data set which I have shown you, it's a mixture. Numerical values are there. At the same time, categorical values also there. And there is no missing value. All the columns have valid entries. And customer ID, you can see, it is just an identifier. It is not useful for training. So now handling missing data. If there were missing values, say someone didn't provide their income. So fill the missing value. So how can we fill the missing value? So there comes the application of statistics. You can take the mean of remaining value or the median. If it is a category, you can take the mode, or you can drop the rows if too many values are missing. So these are steps to handle missing data. Then encoding categorical data. ML models can't directly understand text-only numbers. So we must convert categories into numerical form. Then features scaling. So normally we are using two things, normalization and standardization. They are actually different. Normalization means we are converting the value between 0 and 1. Standardization means take the group of values and make its mean as 0 and standard deviation as 1. So these are the two steps. See, what is the need for this? So features, like we have different features. In our data set itself, we can see different features. Income was there, time on app is there, spending score is there. And they are all actually on very different scales. So most of the machine learning algorithms perform better when all features are on similar scales. So sometimes we have to apply scaling methods. And the two commonly used scaling methods, normalization and standardization. Then we have a lot of features. We don't want to use all the features. We need to use only the required features. We keep only the features that influence the purchase. See, we have customer ID. Customer ID was there in my data set. But there is no role customer ID plays while purchasing. So I just want to remove it. So I'm keeping only 4 features: age, income, spending score, and time on app. Only 4 features I'm keeping in my data set. So now the splitting. Already in the machine learning life cycle, I have shown you training, testing is required. Training is required, validation is required, testing is required. I have shown you. So for that training and testing, we can split the data set. 80% for training, 20% for testing. And if you want, you can use visualization. You can plot different graphs. So this part covers pre-processing. So as per the life cycle, we started with the problem definition. Then we collected the data. I have shown you a data set with 5 records. Then we applied pre-processing on the data set. So now we have a problem, and for solving the problem, we have a data set. Now, problem is there, data set is there. Then how to solve it? So for solving, we are using machine learning. There are so many machine learning algorithms available. So before that, what is machine learning? Machine is learning from data. We have the data with us, right? We have the data with us. From that data, machine is learning. So machine can learn in different ways. It can use supervised method for learning. It can use unsupervised method for learning. It can use reinforcement method for learning. So what is supervised learning? Normally what we are doing in our class. Our students are learning from teachers, right? So there is a supervision. The students are learning from the supervision of a teacher. Unsupervised learning. Simply, when we are giving tutorials, when we are giving assignments, students sit together and they derive the solution. That is unsupervised learning. There is no supervision. Then reinforcement learning. Trial and error. I did this. If I get good score, I repeat the same. If I am not getting good score, I change my pattern of solution. So that is what reinforcement. So mainly 3 ways the machine is learning from the data. They are classified as supervised, unsupervised, reinforcement. So we'll see what is supervised learning. Supervised learning is like learning with a teacher. The algorithm is trained using a labeled data set, meaning that each example in the data set has a known output or label. So here, this is our data set. So in this data set, you can see a label. So here that label is purchased. Like why we are analyzing the customer behavior? What is the aim of analyzing customer behavior? That is my problem statement. The aim is, normally this customer behavior analysis is done by companies. They are doing advertisement. The main aim is they want to know whether the customer will purchase or not. Ultimately, they want to know whether the customer will purchase the product or not. So that purchase, that is the output. So we already have a data set with 5 records having features. Along with the features, there is an output or there is a label. We can use the terms interchangeably, output or label. That is, here in this data set, it is purchased. So I am giving the data set with a label purchased. So you can see first row it is yes, second row it is no. Like you can see the data set. So this is a data set with a label. Let us say we want to predict what I said, I am explaining now. Let us say we want to predict if a customer will make a purchase. So based on features like age, income, spending score and time on the app. So input features, I already explained to you, age, income, spending score, time on app. Then what is the output? Purchased or not? I told you already, you can use output or label interchangeably. So here you can see the input features, age, income, spending score, time on app. These are the input features. And what is the output? Purchased. See, what we do normally. Forget about the machine learning. What we do normally. From this, we will create a pattern. Yeah, if the customer is having age this, if the spending score is this, yeah, he will purchase. So we will generate patterns, right? So the same way, the machine learning algorithm learns patterns between the input features and the output. We know what are the input features and what is the output. So from these two, what we do, the same way machine also learns patterns. How does the algorithm learn? The model uses the data set to recognize relationships. For example, a customer with a high spending score and more time spent on the app, that is time on app, might be more likely to purchase. Customers with low spending score and less time spent on the app may not purchase. So once the algorithm has seen enough examples, it can predict whether future customers will make a purchase. So we want to predict. So we want to predict based on the existing data. Listen, we want to predict, or the machine wants to predict based on the existing data. So what the machine will do, learn from the existing data, then predict. So I told you we have 3 categories: supervised, unsupervised, reinforcement. So what is supervised? I already told you our data set, the one which I have shown you earlier, having different features with a label, and the label was purchased. So what I show you is a labeled data set. That means the data set we are using for supervised learning. So now we can see what are the different supervised learning algorithms. How can we apply them on the given data set? So there are so many algorithms. I have taken most important 8 algorithms. There are so many algorithms. So you can see here the different supervised algorithms: logistic regression, decision tree classifier, random forest, support vector machine, KNN, that is K nearest neighbors, naive Bayes, linear regression, and neural networks. These are the main supervised learning algorithms. So we'll see each one. We'll start with logistic regression. Okay. So what is logistic regression? So immediate answer is it is a machine learning algorithm. It comes under the category supervised learning. That's all. The first step. Then second one. What is our aim? What is our goal? What is our objective? We want to predict whether a new customer will purchase. See, we have a data set already. So what is our aim? When a new customer comes, we have already 5 records in our data set. If a 6th customer comes, we have to predict whether he will purchase. So for that, we have to use existing data set with features, age, annual income, spending score, and time on app. Because the target variable has only 2 outcomes. Purchase is a feature having 2 values like yes or no. We are using logistic regression. It is a supervised learning algorithm. It is ideal. What logistic regression do? Logistic regression predicts a probability. It answers the question, what is the probability that this customer will purchase? What is the probability that this customer will purchase? So, we know always, it is always, probability is always between 0 and 1. So 0.82, that means 82% chance of purchase. That means, yes, obviously, he will purchase. And 0.12, that is 12% chance of purchase. He won't purchase. We can set a threshold. Like if it is above 50%, he will purchase. Below, he won't purchase. Like that, we can set a threshold. So what does logistic regression do? It is a supervised machine learning algorithm. It predicts the probability. Now, how it will predict the probability? So first, the logistic regression calculate a weighted sum. So you can see an equation here. Z equal to W1.age plus W2.income plus W3.spending score plus W4.time on app plus B. B is bias. So we have to convert this into a probability between 0 and 1. So we have Z is with us. Then what we do, we will pass Z through a sigmoid function. Sigmoid function we know it is 1 by 1 plus e raised to minus Z. So to that Z, we will pass the weighted sum. So listen, age is with us, income is with us, spending score is with us, time on app is with us. So what we have to do? Example, customer A, his age is 22, income is 25, spending score is 95, time on app is 12 hours. So these features likely produce a high positive Z. So the probability is purchase equal to 1. Yes, he will purchase. Probability of purchase equal to 1 is 0.91. That means he will purchase. Another customer, age is 40, income is 85, spending score is 45, time on app is 5 hours. This produces a low or a negative probability, like purchase equal to 1 is 0.18. That means he won't purchase. That means how the model learns parameters. See, listen. This is the equation. See, when we are asked to apply logistic regression on your data set, we have the field. I hope you remember the field. Age was there, income was there, spending score was there, time on app was there. So when a new customer is coming, his age is with us, his income is with us, his spending score is with us, his time on app is with us. And we can fix a bias. So what is not with us? We don't know what is W1, we don't know what is W2, what is W3 and W4. And what is B? Suppose at the training time, we don't know what is B. So what we have to find? We have to find W1, W2, W3, W4 and B. Right. So these are the things we have to find out. They are known as parameters. What we have with us? Age, income, spending score, and time. They are actually variables. So we have to find parameters. That means in other way, the machine has to find parameters. In other way, the machine has to learn parameters. From where? From the existing data set. So we have a data set already with us with 5 records. So from that 5 records, they are not simply records, they are records having input features plus a data label. So from that, the machine has to learn values of W1, W2, W3, W4. They are actually parameters. So logistic regression is a parametric model. It learns using parameters. So how these parameters are learned? So once the parameters are learned, see, after training or after training with the 5 records, if I got the values of W1, W2, W3, W4, it is fixed. The machine learned the values, it is fixed. Now if a new customer with age 45, income 1000 is coming, just apply the age, income, spending score on the equation. Already W1, W2, W3 are learned from the data set. So just apply the variable values. So this is what actually happening in machine learning. So how? The model learns the parameters. W1, W2, W3. It does this by comparing predictions versus actual purchase. Adjusting the weights to reduce error using an algorithm called gradient descent. So these are the 3 steps. See, what we have to do is simply assign some random values to W1, W2, W3 and W4 and B. Assign some random values to these parameters and then perform the prediction. Then compare the predicted value with actual value. Already we have a data set with 5 records and the 5 records are having the actual output also. Whether he purchased or not, we know the actual output. It is there with us. So what we have to do? Assign some random values or initialize W1, W2, W3, W4 and B with some random values. Then predict. Then compare the prediction with actual value. If it is not equal, there is a problem in our weight. Adjust the weight. Again do the prediction. So do this until we get a correct value. So adjusting the weight means it's not simply correcting the weights. There is an algorithm for that. If our predicted value is not equal with the actual value, we are not simply correcting the weights. There is a formal method to correct the weights. That we can do using an algorithm called gradient descent. Gradient descent is actually an optimization algorithm. It will produce optimal weights which generate very less loss. A reduced error. You will get a reduced error. Gradient descent is an optimization algorithm. It produces an optimal weight value. That weight value will generate a very loss or very less error. So this is what happening in machine learning. So this is an example. Logistic regression is an example for a supervised machine learning algorithm. So what we did, we have to analyze the customer behavior. So that is our problem. Second thing, we need a data set. We have the data set. I have shown you a data set. The data set having 5 records, having number of input field and 1 label. That is the last column. So from this, we have to infer the pattern. So for that, we are using one of the algorithms called logistic regression. What is logistic regression? It will predict the probability. So for predicting the probability, we have to use a sigmoid function. That is 1 by 1 plus e raised to minus z. It will give you a probability between 0 and 1. 1 by 1 plus e raised to minus z. So what is z? Z is actually a weighted sum of these features. What do you mean by weighted sum of features? That is W1 into age plus W2 into income plus W3 into spending score plus W4 into time on app plus B bias. So this is the weighted sum. And if a new customer comes, we know his age, we know his income, we know his spending score, we know the time he spent on the app. And we don't know whether he will purchase or not. That we can predict. How? Already Our model learned the weights W1, W2, W3, W4, B from the data set using logistic regression, right? So the weights are already learned. So now just apply the variables into that equation. You will get the result. So this is what happening in machine learning, and one of the algorithms is logistic regression. Now, the next algorithm for machine learning, which comes under supervised learning category, is a decision tree classifier. Decision tree is a model that learns if-else rules from the data. Actually, we are creating a tree. We know a tree. What is a tree? It shows a hierarchical relationship. We learn trees in data structure. So we know what is a tree. And here we are creating a tree using if-else rules. Then finally, we have to predict whether the customer will purchase or not. Already we used an algorithm called logistic regression. Now we are using another algorithm, decision tree. So you may be confused, like we already solved the problem, then why we are using another algorithm? We'll see number of algorithms. Then I will tell you finally why we are learning this much algorithms for a particular problem. So here we are using decision tree classifier. A decision tree repeatedly asks question about the features to split customers into groups. At each step, it chooses the best feature and best threshold that separate yes buyers from no buyers. It uses metrics like Gini impurity, entropy, information gain. These measure how pure a group becomes after splitting. So now I will explain. Please see, this is our data. I will explain what I told you now. This is our data set. So how can I create a tree from this? We know always a tree starts with a root. So from the root, we divide the tree into branches. So we have number of field here. Age is there, income is there, spending score is there, time on app is there. And what we have to predict, whether he will purchase or not. That is our label. So we have to consider the 4 field. So which field I have to use to create the tree? Which field should be the root? Suppose age is the root. Then for the next branch, which one I have to choose? Spending score, income, or time on app? Like which field I have to choose as the splitting criteria? That is an important question. When I am creating a tree, I have to split to create branches. So which criteria I have to use for splitting the tree? So for that, we can use metrics like Gini impurity, entropy, information gain. So these are the metrics which select the best criteria to split a tree. So step-by-step explanation of how a decision tree classifier would work on the data set. So here I am using, among these, Gini impurity and information gain, I am using information gain as the splitting criteria. So a decision tree tries to split the data so that each group becomes as pure as possible. What do you mean by a pure group? If all the entries are yes, if all the entries are no, it's a pure group. If it contains mixes, yes or no, yes, no, then it is not pure, it is impure. So our aim is to create a group which is as pure as possible. So we are using information gain as the splitting criteria. So for using information criteria, we have to calculate entropy. So this is what entropy of a data set. This is the equation to find entropy. Pi log to Pi. Pi is the proportion of class I. C is equal to number of classes. Don't worry, we'll see the example. You can see here 3 by 5 log to 3 by 5 plus 2 by 5 log to 2 by 5. What is this 3? What is this 2? What is this 5? From this data set, it is clear. The denominator, it includes total number of records, 5. Then the numerator, first it is 3, then it is 2. That means count the values of yes, it is 3. Count the values of no, it is 2. So that is, so 3 by 5 log to 3 by 5, how many yes? Plus 2 by 5 log to 2 by 5, how many no's? So based on this, you can calculate entropy. So this we calculate before any split. So this is the impurity we want to. So this is the impurity we want to reduce. So how it is possible? So we are starting to create the tree. So we start to use the information gain. So listen, you can see here information gain of S, comma A. That is entropy of S minus for all values of A, SV by S, entropy of SV. Please, the equation is like this, but it's very easy to do. And A less than or equal to T and A greater than T. So we'll see what it is. So this is the equation for entropy. This is what we have to do before any splitting. Then we are starting to split. So for that we have to calculate information gain. Attribute with maximum gain we have to use as the splitting criteria. So entropy, information gain. So now compute information gain for all attributes. So now these are the attributes we have: age, income, spending score, time on app. These are the 4 attributes we have. If you look at the data set, these are the 4 attributes. Then you can see here in our data set, the ages, they are numerical values: 25, 40, 22. Income, again numerical value 35, 85. Spending, so these are all numerical values. So when you handle numerical values in decision tree, what we can do is take the midpoint, sort them and take the midpoint. So for age, these are the values given in our data set: 22, 25, 30, 35, 40. So take the midpoint. Now we compute information gain. IG means information gain for all these splits and choose the best. So I'm computing information gain for all attribute. So these are the values, ages. Then I calculated the midpoint: 23.5, 27.5, 32.5, 37.5. So now I am calculating information gain for all these midpoint values. Okay, so how to calculate information gain for all these? So first, you can see I have to, listen, I have to calculate information gain for all these: 23.5, 27.5, 32.5, 37.5. So first I am taking 23.5. So see, when you create a tree, when you divide a tree, it is having left child and right child. So less than or equal to 23.5 and greater than 23.5. This is the splitting criteria. Then under this category, less than 23.5, the customer ID is 103. I think it's having age 22. That is less than 23.5. And its value is yes. Only one value is having, only one record is having age less than or equal to 23.5. And that is the record with customer ID 103. And its label is yes. So only one yes. There is no 0. Then again, the right side, greater than 23.5. So there are 4 records having customer ID 101, 102, 104, 105. And the count of yes, 2 yes is there, 2 no is there. See, first case, in the left case, there is only one yes. That is a pure class. Only yes is there. But in the right side, it's a mix of yes and no. So it is not pure, it is impure. 2 yes and 2 no. So that is why the first case, it is pure. So the entropy, the impurity is 0. In the second case, it is a mix. So there is an entropy that is 1. So now this entropy is actually after the split. We already calculated one entropy before the split. This is actually entropy calculated after the split using the value 23.5. So now how to calculate information gain? So information gain is actually, we already calculated an entropy before splitting, right? That is 0.97 minus 0.8. What is 0.8? 0.8 we will get from this split. That is 1 by 5 of 0. Less than or equal to 23.5, the entropy is 0. Then greater than 23.5, the entropy is 1. So 4 by 5. How many records? 4 records out of 5. So 4 by 5 and the entropy is 1. First case, how many records? 5. How many yes? 1. So 1 by 5 and the entropy is 0. So 1 by 5 into 0 plus 4 by 5 into 1. That is the calculation. So we will get an entropy after split, that is 0.8. So subtract this impurity from the already calculated impurity. So the answer is 0.1704. This is the information gained when you use the splitting criteria as age less than or equal to 23.5. The same way, if I calculate age less than or equal to 27.5, the same thing, I don't want to repeat it. The information gain is 0.4195. When it is less than 32.5, it is 0.9704. Less than or equal to 37.5, it is 0.321 for the same calculation. That's why I am not repeating. Now, age part we completed. We have other attributes also. Spending score, income, time. I don't want to do all the calculations again. I did the calculation already. And then from that, I got a conclusion that other than age, the other attributes, spending score, income, time, all of them having information gain less than 0.20. None of them reduced entropy to 0. So they are inferior to age. Then, so now we have to consider only age. And in the case of age, which one is best? Less than or equal to 32.5, right? We already identified several splits for age. And among them, the best one is less than or equal to 32.5. The same thing you have to do for other attributes. Since it's a waste of time, I don't want to do that. I just calculated and I got the conclusion that for all other attributes, it is less than 0.20. So now, they are all actually inferior to age. So I have to focus only on age. So among the age splitting criteria, the best one is 32.5. You can see the tree now. It starts with the root age. And it is divided into two branches, yes and no. So now, yes is pure, only yes, no. You can see this, right? So here, it's over. The decision tree is over. So if the customer, a new customer is coming, it is compared like this. Okay. So this is what happening in decision tree. Now, suppose I'm making some changes in the data set. I did some changes. I applied some changes in the data set. It was not the previous one. So what happens? It won't work as previous. Everything changed. Everything changed. So the information gain for age, it looks like this is the splitting criteria. It was not 32.5. Since I changed the data set, now it is 37.5. See, already I created a decision tree with the original data set. So that have only root and left child, right child. That was only one level was there. But when I changed the data set, you can see left side is impure. That means still I have to divide it. If it is pure, I can stop. But still it is impure. So I have to further split. I have to again split. So again I have to do the calculation. So next time, spending score. Again repeat the same thing for the next level. Now this time, among the remaining attributes, age was already there. Then the remaining was spending score, time on app, income. Among them, the best one was spending score. Now again, it is yes and it is no. So here one more level is added when I changed the data set. So in this way, you can create decision tree up to any level. You have to create decision tree till you will get a pure group. So this is what actually happening in decision tree. Another algorithm that comes under supervised learning is random forest. So it follows the rules of decision tree. That's why I am taking random forest immediately after decision tree. Random forest, we know what is a forest. A simple word, what is a forest? It's a group of trees. So a number of decision trees. That is what random forest. It is an ensemble algorithm. It is made by combining many decision trees. So how can I do this? The different steps involved in random forest. First one is bootstrapping. Second one, random feature selection. Third one, make a prediction. Then voting. So these are the things. These are the different steps in random forest. So what is the first step? Bootstrapping. So what do you mean by bootstrapping? Randomly sampling the data with replacement. See, here I am creating. See, I already told you random forest means it's a group of trees. You can see tree 1, You can see tree 2. You can see tree 3. Number of trees I have created with the same data set. But I made some adjustments. The first one is 101, 103, 105, 105, 104. Again, so in this way, a random sample is taken. Number of trees I have created. Then for each tree, I compute the information gain. Then from that, I took the bus split, completed the tree. Then I made prediction. What I did for a decision tree, I did the same procedure here also. So I predicted for tree 1. I did the prediction for tree 2. I did the prediction for tree 3. Another way to create number of trees is actually random feature selection. At each split, instead of evaluating all features, each tree evaluate only a random subset. For example, tree 1 consider age and spending score. Tree 2 may consider income and time. Tree 3 may consider age and income. So this prevents all the trees looking identical. So in this way, in random forest, just remain one thing. The first thing is create so many trees. The first thing is create so many trees. And for each tree, how can we create a tree? We need to find the splitting criteria. How can we find the splitting criteria? We have to use one of the metrics. And the metric I used is information gain. So I used entropy. I used information gain for finding the best split. Then using the best split, I divided the tree until I got pure group. So everything, the same procedure I did for tree 1, tree 2, tree 3. Then I made predictions. Based on the tree, I made predictions. Now, see, each tree makes a prediction. See, suppose I want to predict for a new customer. It is not in the data set. It's a new customer. His age is 28. His income is 45. Spending score is 80. And he spends around 8. There is a time on the app. So whether he will purchase or not. So I have to use the decision tree. I have to follow the path. Then I can tell whether he will purchase or not. See, these are the features. So from this feature, I have to predict whether the customer will purchase or not. It is not in the data set. It is an unseen data. It is not in the training set. It is an unseen data. See, whatever we did in logistic regression and in decision tree, we already have a data set. From the data set, the machine learning. The machine learns a pattern. That is actually from the data set, the machine learns a pattern means it is training. From the data set, the machine learns a pattern. I already told you. I am initializing some random values for the weight. Then check whether the predicted and actual is correct. If not, again change the weight. So I repeat this. That means I am doing training. The machine is learning from training. So now I want to predict. That is, I am using an unseen data. That is, I am testing. So whatever machine is learned, that is through training. Then now I am predicting. That is, I am testing with an unseen data. So here, this data is not in the data set. So I have only 4 features. I don't know what happens in purchase. Whether he will purchase or not, I don't know. So what I do, I will use tree 1. In random forest, I will use tree 2. I will use tree 3. Tree 1 says yes. Tree 2 says yes. Tree 3 says yes. So finally, I have to take voting. So the majority predicts. That means 3 votes for yes. No, 0 votes. So finally, the result will be yes. So this customer will purchase. So in random forest, it gives more accuracy because it depends on different trees. If I am using a single decision tree, it depends on only that particular tree. Here I am using different kinds of trees. So, and then I take the prediction. Then I am taking the count. How many predicted yes? How many predicted no? From that, I can say the majority predicted yes. So it is yes. So in this way, I can use random forest. So we identified 3 supervised machine learning algorithms. First one was logistic regression that create or that generate whether a probability, what is the probability the customer will purchase. Second one was a decision tree classifier. We will create a tree. Then when I have to predict something, I will pass through the tree. Then I will predict. then more number of trees. It creates another supervised learning algorithm, that is random forest. Now we are going to see the fourth machine learning algorithm, that is support vector machine. It is a supervised machine learning algorithm. It is again a supervised learning algorithm for classification. It tries to find the best possible boundary that separates yes and no customers. Again, we are taking the same data set. Here, just look at the right diagram, not on the left, the diagram on the right side. Two classes you can see, red circle and blue squares. Two categories, like yes or no, two categories are there. They are on the left and right side of a decision boundary. And decision boundary you can see, along with that, the decision boundary is a dotted line. On the right side and left side, you can see solid lines. So that solid lines actually hyperplanes. Then you can see one red circle on one of the hyperplanes, blue squares, another hyperplanes. They are actually support vectors. So our method is known as support vector machine. So what we have to do is the distance between these, from this diagram, you know what is support vector. What is support vector? There are so many red circles, but I haven't considered them. I have considered only the one red circle which is very close to my boundary. 1, 2, 3, around 6 circles are there. I didn't consider the 5 circles. I consider only the one circle which is very close to my boundary. Again, you can see there are so many blue squares. Among them, I had taken only 2 squares which are very close to my boundary. So, the values which are very close to the boundary, they are actually support vectors. So, I have to make a margin which provide maximum distance between these two. So, you know what is support vector? So, I have to create a hyperplane which provide maximum margin. You can see from the diagram what is a margin. So, how can I generate that maximum margin? How can I provide a hyperplane with maximum margin? So that I can categorize red on one side, blue on another side. This is the aim for support vector machine. Obviously, we have to categorize them into 2 categories. If I am giving a red circle, it should go to the red side. If I am giving a blue square, it should go to the blue side. But how? For that, I have to make sure the difference, the boundary is having as a margin which is as large as possible. So this is the basic concept of support vector machine. So now we will see what is support vector machine. If you see the definition again, it is a supervised algorithm. It is used for classification. It tries to find the best possible boundary that separate yes and no customers. Again, I am using the same data set. So what we normally do, we first plot all the data points on the graph. Then we draw a line that separate yes and no classes. So we can see in this diagram also, red is there, blue is there. In between, I can draw so many lines. I can draw so many lines in between. What SVM should do? SVM chooses the best possible line. That means the one that gives the maximum margin between the 2 classes. And the best line, how can I draw the best possible line? That is what the aim of support vector machine. What is the advantage of having this best line? Wider the margin means more confidence, better generalization, less overfitting. What do you mean by overfitting and generalization? See, if my algorithm works for a specific data, it is not generalized. My algorithm should work for all the data. That is what generalization. If my algorithm works very well for a specific set of data, but it won't work for general data, that means the model is having overfitting. So we don't want that. We don't want overfitting. The model is good in training, but the model can't do predictions for an unseen data. That means it is having overfitting. It's good for training. It is good for training data. We don't want that. What we need, our model should predict good. It should have good accuracy on unseen data also. So if wider margin means overfitting is less. It is good for all unseen data. That is what better generalization. It is not for a specific problem. I can use it for, it is not for a specific data set. I can use it for any data set. That is what better generalization. So if you having widest margin means it gives more confidence, it gives better generalization and less overfitting. So how can we do this? What is the SVM equation? So I have a data set. I hope you remember. In the data set, we have around 4 features. But here I am taking only 2 features, x1 and x2. So assume I am taking 2 input features, x1 and x2. So w1 x1 plus w2 x2 plus b is equal to 0. So this is the equation. So this line divides the plane into 2 classes. That boundary, dotted line, that is. Then it's dotted line having a left side and it's having a right side. If the value is greater than 0, it is yes. If it is less than 0, it is no. If it is equal to 0, that is the boundary. And then greater than or less than. That depends on yes or no. So margin means if yes, it is having wx plus b is greater than or equal to plus 1. Otherwise, it is less than or equal to minus 1. So now, again, we did the same kind of approach in logistic regression. There also, we named the model as a parametric model. SVM is also a parametric model. So my question, what about decision tree? It is not a parametric model. It is a non-parametric model. Decision tree is a non-parametric model. But SVM, logistic regression, they are all parametric model. We have to learn parameters. When I discussed decision tree, I didn't mention anything about weights. We just follow if-else rules, right? I didn't mention anything about weights. So it is not a parametric model. It is a non-parametric model. But when we discuss logistic regression and SVM, there are weights along with variables. So that weights are actually parameters. We have to learn parameter. So here also SVM is a parametric model. So now x1 and x2 we have with us. They are variables. What about w1 and w2? So how to learn w1 and w2? In the case of logistic regression, what we learned, we initially assigned random values. Then we checked predicted and actual value. If it is not correct, we applied gradient descendant to change the weight, to find optimal weight. But what happens here? Here, what do you mean by W1 and W2? SVM solves an optimization problem to get W1B. What is that? So we know that a decision boundary is equal to 0. Positive means plus 1. Negative means minus 1. So what is the distance between this positive and negative? When you solve linear equation, linear algebra, when you apply linear algebra, wx plus b is equal to plus 1, wx plus b is equal to minus 1. When we solve this, you will get the margin as 2 by w. So if I want to increase the margin, according to this equation, I have to minimize w. So this is the core concept in SVM. I have just enlarged the diagram. Support vector, what is the separating hyperplane, what is the margin? The same diagram I have enlarged. So now, distance from plus 1 margin line to origin, that is 1 by w. Distance from minus 1 margin line to origin, that is, then when we add, you will get 2 by w. So this is actually the margin 2 by w. So this is actually we have to maximize. So to maximize this, what we have to do? Minimize w. So that is actually an optimization problem. I don't want to get into that details because it applies an optimization problem with a constraint. We have to apply Lagrangian multiplier. So it is a complex problem. I don't want to include that in my session now. So we have to find out w here. Okay. So what is SVM? This is a binary classification problem. Convert target to numeric form. SVM works better with numeric classes. So yes, we can convert to plus 1. No, we can convert to minus 1. So SVM will try to find a line. Here in our data set, we have 4 features. A hyperplane in 4D is the result. So these are the features. Initially, I had taken only 2 features. That's why my equation was W1x1, W2x2. If you combine all the 4 features, it is like W1x1, W2x2, W3x3, W4x4 plus B equal to 0. Then apply optimization to find the values of W1, W2, W3, W4. It is not like gradient descendant. Here, what we have to do? We have to find W1, W2, W3. You have to use an optimization equation that I already told you. We have to apply Lagrangian multiplier. You have to find the Lagrangian multiplier value, everything. So this is what SVM. Now we will move to the next algorithm, supervised learning algorithm, that is KNN, K nearest neighbors. Another supervised learning algorithm. So the specialty is here we don't need any training. There is no training phase. So for a new data point, that means already we have 5 data with us in the data set. If I want to predict something for the new data point, it looks at the K close customers based on all feature values. So if I want to predict whether he will purchase or not, what I have to do? I have to take K close customers. That means K customers, they are very close to this new one. Then what they predict? Based on that, I can predict the value for this new customer. I am looking at his neighbors. Then what they are doing, I am doing the same here. That is why it is nearest neighbors. The class of majority of the nearest neighbor will be equivalent to the prediction. That means in K nearest neighbor algorithm, K is just a number that tells the algorithm how many nearby points or neighbors. Suppose K is 3. You have to look at 3 close customers. If K is 4, 4 close customers. Then what do you mean by that closeness? How can we decide whether a particular customer is very close to this new one? So for that, we can use some distance metrics, distance measures. There are so many distance metrics we commonly use. The one I have used is Euclidean distance. You are all familiar with Euclidean distance. So I have to apply this Euclidean distance with all the features. Then I have to identify, suppose my new customer is having age 28, income 50, spending score 70, and time on app 8. This is my new customer attributes. And I am choosing K as 3. I have to predict whether this new customer will purchase or not. So what should I do? I have the new customer values and I am choosing K as 3. So what should I do? I have to find, since K is 3, I have to find 3 customers from my data set. They are very close to this new customer. So how can I find 3 customers? They are very close. How this closeness I can measure? I am using a distance metric called Euclidean. So I have done the calculation here, applied the equation with all the customers, find the distance. I have taken all the values and the top 3 are very close to this. Distance is very less. Then I am taking all of them predict yes. So the majority is yes. So the answer will be yes. The new customer will also purchase. Yes. So in this way, take the new values, then apply a Euclidean distance metric with the new and the existing data set, find values having less distance based on K, take the values and then take the majority. So the advantage is we don't have any training here. But the problem is actually machine learning algorithms are very fast compared to deep learning, but algorithms like KNN, when we compare at the testing time, they are actually takes more time at the testing time than deep learning, because in these kind of algorithms, everything is doing at the testing time. We don't have any pre-training. We don't have any learned values. So what they are doing is, it is also a non-parametric model. We don't have any parameters like weights. We are doing at the time, comparing. So it will take time when you test, because everything is calculated at the time of testing. So this was another algorithm for machine learning, supervised learning. The naive Bayes, it is also a probabilistic algorithm. Another supervised learning algorithm comes under machine learning as naive Bayes. It is also a probabilistic algorithm. It also answers what is the probability this customer will purchase. Then you may confuse, is there any relationship with logistic regression and naive Bayes? No. Logistic regression is actually a discriminative model. Naive Bayes is actually a generative model. What is the probability this customer will purchase? From the data, we'll calculate the probability. So I will show you an example with our original data set. So this is our original data set. So what we have to do is, first we have to calculate the prior probability. We know the total records are 5, 3 yes are there, 2 no are there. So we know the probability of yes and no. The prior probability we know. Then what we have to do next? See, here you can see the feature is age. The feature is income, spending, time for yes. The same features for the class, no. We have only two classes. He will purchase or not, only two classes, yes or no. For S, we take all the features. For no, we take all the features. Then the values. Since the values are numbers, the value type is numeric, we have to do a Gaussian probability analysis. It is not categorical, it is numeric. So when we do naive Bayes for numeric values, we have to take a Gaussian analysis. So we have to take mean and variance. I have calculated its mean and variance. Now, what I have to do? A new customer is coming. His age is 28, income is 50, spending is 70, time he spent is 8. So what I have to do? Only two classes, yes or no, right? So I have to find yes into x given yes. Probability of no into probability of x given no. Which one is greater? That I have to choose. So what I will do? For prediction, apply, since it's a numerical value, Gaussian naive Bayes for each feature. So what I am doing is, see, listen, you can see here, this is what I have to find. Probability of x given is probability of yes. Probability of x given no, probability of no. This is what I have to find. What do you mean by this 0.0524? What is this point? You know what is 0.6? That is the probability of yes. Under class no, what is 0.4? That is the prior probability of no. That we know. Then what are the other values? Other values 0.0524, 0.0247. 0.0524 is for age. Next one is for income. Next one is for spending score. Next one is for time. The probability when it is yes. The next one, the probability of age, income, spending score and time when the class is no. How can you find it? Using this equation. So apply this equation for all. This equation is everything is available. Variance we already identified. Mean we already identified for each feature. Just apply that. We already identified the mean and variance. Just apply this corresponding to each feature on this equation. You will get its probability. Class, that means age given yes. Income given yes. Identify is for yes. The same thing do for no also. Then that is what you have applied. I have applied here. Then along with the prior probability, you will get the value. So now just normalizing it. And what I can understand, which one is higher? Probability of yes is higher. So from that, I can say the new customer will purchase. So likewise, identify the prior probability and the probability of each feature based on the class. Multiply. Which one is higher? Yes or no? Take that. It's very simple. So this is what naive Bayes. It is also deals with probability. This is also one of the supervised learning algorithm for machine learning. Then the linear regression. So linear regression is another algorithm. Comes under supervised learning. It comes under regression category. Whatever we discussed till now, actually classification. See, I can't say it is pure classification because decision tree we can use for regression also. But normally we categorize them under classification. For regression, there are so many varieties, but I am dealing only with linear regression. What do you mean by linear regression? It predicts continuous values. Like suppose I am asking whether I will get promotion. Yes or no? It comes under classification. How much increment will be there? Then it is a number. It is a numerical value. So it comes under regression. So linear regression is a statistical method which is used for predictive analysis. It shows, the name itself implies a linear relationship between a dependent and one or more independent variable. See, y is equal to mx plus c. So what is dependent? Y, the output. Input variables are independent. So this is what linear regression. It shows the linear relationship, which means it finds how the value of dependent variable is changing according to the value of independent variable. So normally we use this method for predictions of continuous value, numerical variables, etc. See, a best example, a very common example, predict the price of 1,000 square feet house. We already have, I'm not taking my previous data set. We did all the classification on that because that was for classification. Now I am taking another data set with two field, around 7 records, 2 field, square feet and price. Then you can see Square feet with value 1000 is not there. It is an unseen value. So I have to predict the price of a house having 1000 square feet. How could I predict it? So I am using linear regression because I have to predict the price. It's a numerical value, it's a number. So I am using linear regression. So how can I use linear regression for that? So just look here. So many things I have written, but you just look at the equation y is equal to mx plus c. Linear regression, this is the equation, y is equal to mx plus c. So my question is, what is x? My input is 1000. I have a house having square feet 1000. So my x is 1000. And now I have to predict its price, that is y. How can I predict its price y? I need m and c also, right? Only with x I can't do anything. So here, linear regression, it is a parametric model. Two parameters are there, m and c. X is a variable, that is with me, 1000. How can I find m and c? Here, you can see above, m I found as 0.0138 and c I found as minus 2.5462. How I got this m and c, or how the machine got this m and c, how the machine learned this m and c, likewise w1, w2 in logistic regression, how this m and c machine learned this m and c from this data set. From this data set, the machine learned m and c. How? There is an equation. See, you can see an equation here for m and b or c. It varies. Mx plus b or mx plus c, anything. So here you can see an equation for m and b. How this equation is derived? See, you need m and c. The machine got m and c. How? From this equation. How this equation is derived? Actually, one second. Sorry. Okay. This is the equation for linear regression. Y is equal to mx plus b. See, we have to apply some derivations. We have to compare actual value and predicted value. Then we have to find the error, sum of squared errors. Then we have to apply some derivatives. So many steps are there in the derivation. Finally, you will get this equation. So what machine is doing? There comes our role. What machine is doing? When I am giving this much data to the machine, from this data, machine will learn m and c. How the machine will learn m and c? Using this equation. The machine will learn m and b or m and c from this equation. So the parameters machine learned m and b using this equation from this data set. Now, a new value comes, 1000. It is not in the data set. What it will do? Just apply that x here. Already m and c machine learned from the data set. Apply the input. It will predict. So this kind of prediction is happening in linear regression. And it is regression. Why? Because it predicts a number. It is not a classification like yes or no. It predicts a number, a continuous value. That is why. Another category of machine learning, what we identified till now, a supervised learning. Different supervised learning algorithms we identified. What was supervised learning? We have a data set. In the data set, we have a label. What was the label? In previous case, whether he purchased or not, he or she purchased or not. Just sometimes before we identified another data set with square feet and price. There was also a label. What is that label? Price. Input feature is square feet. The label was price. So whatever data set we identified till now, it is having a label. We use label data set for supervised learning. Now, unsupervised learning. There is no labeled data. Only input features. So unsupervised learning is a type of machine learning where the model is given data without labels. We don't tell it the right answer. The goal is to discover patterns or structures hidden in the data in its own. So there are two types of unsupervised learning, clustering and dimensionality reduction. So there are so many clustering algorithms, k-means, hierarchical clustering, density-based scan, Gaussian mixture models. Then there are so many dimensionality reduction techniques, PCA, TSNE, autoencoders, self-organizing maps. So I don't have enough time to cover all these things. What do you mean by k-means clustering? What do you mean by k-means clustering? Suppose I am asking you what is k-means clustering. The immediate answer is it is a machine learning algorithm, comes under the category of unsupervised learning. That means I have a data set with only input features. I don't have any label. This much you can simply say. Then from the data set, what I have to do? Suppose I have around 10 records with me. I have around 10 data with me. So what I have to do? The name itself implies k-means clustering. That means cluster means we know it is a group. I can create k groups, k clusters using mean. That is the meaning. K means clustering. I need k clusters, and the k clusters I found using mean, that is average. So what I have to do initially, from the 10 data set, suppose I need 2 clusters, k is 2. I will randomly select 2 values from the data set as clusters. Then there are remaining points, 8 points remaining. Then I compare the distance between the remaining points and the clusters. Then the close values will come to that particular cluster. So normally 2 clusters will be formed. Again, I have to find the mean. Again, that becomes the next centroid. So in this way, I will repeat this. I will find new centers at each iteration. So I will repeat it until a convergence. That means until there is no change in centers in common consecutive iteration. So in this way, I have 10 data set. I divided the 10 data set into 2 groups. If I need 4 groups, fix the value of k as 4. So in this way, if you have a data set, you just divide them into groups based on your application. So what we are doing here is we are finding the distance between cluster centroid and the remaining points. For that distance, we can use any distance metric, Euclidean or anything. So in this way, a data set you can cluster. So here it is based on distance. You are finding the average centroid. That is why it is k-means clustering. Hierarchical clustering. That means, see, we all familiar with merge sort in data structure. Like if you have a tree, you can split it into number of clusters. If you have number of clusters, you can merge them into a single data set. So if you are dividing, if you are doing it from bottom to top, it is agglomerative. If you're starting from top to bottom, it is divisive. Another one is density-based scan. When we are dealing with images, see, sometimes some pixel intensities are very close. So based on the density, you can group points. It is not based on the distance, it is based on the density. So we have to take some other parameters. So there are so many types of clustering. So k-means, hierarchical, density-based scan, these are all different clusters, clustering algorithms. Another one is Gaussian mixture model. You all are familiar with Gaussian mixtures. Each Gaussian model is having its own mean and variance, its own mean and deviation, standard deviation. So based on that, we can assign values into each Gaussian. So these are all different clustering algorithms. Now another one, principal component analysis. See, it actually comes under unsupervised learning because we have to, suppose if I want, it's actually part of feature engineering. Suppose if I have number of features in my data set, I want to reduce the number. I can use techniques like PCA, principal component analysis. I have to find principal components. There are so many steps involved in it. Standardize the data, compute the covariance, compute the eigenvalues, then select the top components, then transform the data into principal components. So I can reduce 3-dimensional or 4-dimensional data into 2-dimension. So it is mainly for dimensionality reduction. Here also there is no label. We have raw data with us. First we have to standardize. Then we have to compute the covariance. Then we have to calculate the eigenvalue, identify the top components, transform. So this is also comes under unsupervised learning because we are extracting patterns from the raw data. There is no guidance, there is no label. Then see, once, I hope you remember the machine learning project life cycle. We started, define a problem, identify the data set, apply pre-processing techniques, identify a model. So identifying a model, there comes this supervised, unsupervised models. So once you fixed one model, you implemented the model, you applied training, You applied testing. So now the evaluation part. How can we evaluate whether this model is ready to deploy? How can we evaluate? There are so many performance measures available like accuracy, precision, recall, F1 score, confusion metrics, ROC, AUC curve. Like so many metrics are there to measure the performance. So here you can see accuracy TP plus TN divided by TP plus TN plus FP plus FN. What do you mean by this TP, TN? TP means true positive, TN means true negative, FP means false positive, FN means false negative. So if I have a data set with me, I predicted something and I want to check its accuracy. How can I evaluate the accuracy? See, I'm doing this for classification models. Okay, I'm doing this for classification. So I have a label data. I have a ground truth value to compare my prediction. So how can I generate the values for TP, TN, etc.? For that, I have to use a confusion matrix. This is what a confusion matrix. You can see predicted side and actual side. Predicted positive, predicted negative, actual positive, actual negative. And then you can see if both are positive, it is correct, it is true positive. If both are negative, it is true negative. So from this, you can calculate the values of TP, FP, FN. Then give that count here. It will generate TP means how many true positive, how many true negative. Apply the value here. You can generate accuracy, precision, etc. So now these are actually evaluation methods for regression models. When we predict a number, when we predict a continuous value, you can use these methods for evaluation. Mean absolute error, mean squared error, and root mean squared error. So now I just want to move into neural networks. Actually, neural network is the starting point towards deep learning. Neural network is actually one of the machine learning algorithms. So machine learning algorithms, now we are moving into deep learning. So what do you mean by deep learning? It is actually a continuation of machine learning. This is actually a neural network. It is not deep. It is a shallow network. One input layer, one hidden layer, and one output layer. It is a shallow because only one hidden layer is there. When the hidden layer number is more, it becomes deep. It becomes a deep learning network. So that is the main difference. When you use neural network for machine learning, the number of hidden layers is less. When you use neural network for deep learning, the number of hidden layers is more. You can see here 3 layers. Input layer, hidden layer, output layer. And each layer you can see x1, x2, x3. What is this x1, x2, x3? So what is a neural network? A neural network is made of artificial neurons that receive and process input data. Data is passed through the input layer, the hidden layer, and the output layer. A neural network process starts when input data is fed into it. Data is then processed via its layers to provide the desired output. Input layer, then it gets processed at the hidden layer, then you will get the output. So input layer, hidden layer, output layer. So what is artificial neural network? It is a computational system inspired by the way biological neural networks in the human brain process information. So what is a neuron? It is a building block of artificial neural network. It is responsible for accepting input data, performing calculation, and producing output. You can see here the inputs, the input variables are x0, x1, x2, etc. x0 is the bias, x1, x2, etc., xn. They are the input variables. And they are assigned, the edges are assigned with weights W0, W1, W2. Then we have to calculate a weighted sum of inputs. Then we are passing the weighted sum through an activation function. Then you will get an output. So that weighted sum, an activation, everything is happening in the hidden layer. And then you will get the output layer. So input with weights, calculate the weighted sum of inputs, pass the weighted sum into an activation function, you will get an input, you will get an output. So this is how a normal neural networks looks. What is an activation function? The function which takes the incoming signal as input and produce the output signal is known as activation function. There are so many activation functions: threshold activation function, sigmoid activation function, TANH, ReLU, softmax. Once again, I repeat: threshold, sigmoid, TANH, ReLU. So these are all activation functions. So what is this activation function? Here in this diagram, you can see F of sigma WI/Xi. What is that F? That is the activation function. When you take a weighted sum itself, it will handle only linear data. If you want to include some non-linearity, if you want to handle non-linear data, you must include activation function. So these are the activation functions for that. Actually, I reached the time. Can I continue or can I stop, ma'am? Organizers, please. Ma'am?
Hello, ma'am. We have a time up to 8 p.m. I think you can continue.
Can I continue?
Yeah, yes, ma'am. Am I audible?
Yes, you're audible. So when I have to stop, please tell me.
I think it's at 8 p.m.
Till 8 p.m.
Yeah, ma'am.
Okay, then it's fine. Okay, ma'am. Okay. So here you can see activation functions. So you can see the working of artificial neural network. And I calculated. Ma'am, 1 second.
Okay.
Okay, ma'am. I will continue. Okay. So this is, I think my slide is visible now, right?
Yes, ma'am. It's
Okay.
visible.
Yeah. Okay, then. So this is the working of artificial neural network. Then since the time is very less, that's why I am moving very fast. I know it takes time. So anyway, this is how an artificial neural network looks like. You have, suppose I have a lot of input features. Suppose I have around 10 input features. X1, X2, X3 up to X10 will be there. X0 is the constant value 1. That is for bias. The remaining features I can give as x1, x2, x3, etc. Then for each input feature, I am assigning weights. Then what I have to do? I have to take the weighted sum of inputs. See, this is how our human brain works. That is why it is known as, we are creating an artificial human brain. That is why it is artificial neural network. In our brain, there are so many layers. From our eyes, when we see something, it comes through our retina, then so many layers behind us: axon, dendrite, synapses, everything. So what happens? There are so many neurons in our brain. So that neuron gets activated. Then only the signal propagate. Suppose I am seeing a mobile phone and a cat. At the same time, my brain will recognize this as mobile phone and this as cat based on the weights assigned to that object. See, the same thing. See, for mobile phone, my neural signals having a particular weight. For cat, there are certain other weights. So the same concept we are imitating here. So the same way we are assigning weights. So we are calculating the weighted sum. Then we are putting it to an activation function. So there are so many activation functions. We identified the activation functions. What is the purpose of activation function? If there is no activation function, the function will deal only linear data. If activation functions are there, it can include some non-linearity. There are so many activation functions. I don't know if you did some machine learning or deep learning projects. You can see the commonly used activation function is ReLU. Why we are using ReLU? Because it reduces vanishing gradient problem. What do you mean by vanishing gradient problem? See how the neural networks actually works. How the neural network works? There are different stages. There is a feed forward moving. It will generate output. We'll compare the output with the actual value. We will then calculate the loss. Then if loss is there, we have to reduce the loss. So we will move back. We will propagate the error back. When we propagate the error back, at the same time, we will adjust the weight optimally. So for that, we are using optimization algorithm like gradient descendant. So what I can do is, the neural networks works like it moves forward, then it produces output based on the activation function. It moves forward, it produces output based on the activation function. Then once the output is obtained, we compare it with the actual output. If there is difference, it's a loss. So we have to reduce the loss. So we'll move backward to reduce the loss. So we are propagating the error backward. So when we propagate the error, we have to adjust weight. So for that, optimized weight, we are using gradient descendant, batch gradient descendant, batch gradient descendant. There are so many algorithms. So in this way, we will adjust the weight. Again, we will feed forward. We'll repeat this process until we get correct output. This is actually happening in a neural network. And in neural network, we have two functions. One is cause function and one is activation function and one is loss function. Activation function we use at the time of feed forward. Loss function we use at the time of backward propagation. So the same thing we can apply in deep learning, only difference, hidden layers are more. So now due to the time restriction, I'm just concluding here. Anyway, I will try to share my PPT. I'm just concluding here because the next resource person is waiting. If you have any doubts, because of the time restriction, it's not possible to complete machine learning and deep learning foundation within 1.5 hours. I tried my level best. I tried to complete machine learning. I don't know how many of you are able to, I don't know. But anyway, I tried my best. So if you have any doubt, you can ask me. I will share my complete slide anyway.
Thank you, ma'am. Thank you so much. The session is open for question and answers. If anybody have any doubt, please be here. Ma'am, from my side, as a participant, it was a very wonderful session, really. And after the session, I'm sure even for beginners, they might be get some basic learning of machine learning, and that's I think that is for today's session.
Thank you, ma'am. Thank you so much.
Please, any queries? Please unmute your mics. Now I'm moving to my duty, a summary of today's session. Dr. Shinu explained how AI has grown over these years from old rule-based system to modern learning-based system that learn automatically from data. She took us through the steps of machine learning project, including data collection, cleaning, preprocessing, etc. And she introduced common machine learning algorithms like logistic regression, decision tree, random forest, etc. Moving to deep learning, she explained the structure of neural network, how neurons, weights, bias, and activation functional model learn. Then overall, the session was very informative, easy to follow, and extremely useful. Dr. Srinu presented the concepts in a simple and practical manner, making it a valuable learning experience for everyone.
Thank you all. If you want to contact me, my mail ID is, I will give in the chat. This is my mail ID.
Okay, ma'am. Thank you, ma'am.
This is my mail ID. If you have any queries or if you want to contact me, you can contact me through this mail ID. Thank you all for the wonderful session. All were very cooperative. Thank you so much.
Thank you, ma'am. Thank you so much.
Thank you, Dr. Srinu, for your wonderful session on ML and TL. Now for next technical session, I formally invite Ajay Kumar sir for the welcome address. Sir, please.
Hello, am I audible? Hello, am I audible?
Yes, ma'am.
A very good afternoon to one and all. On behalf of the Department of Computer Science, Majlis Arts and Science College, I am deeply honored to deliver the vote of thanks for today's insightful technical session on foundations of machine learning and deep learning. First and foremost, my heartfelt gratitude goes to Dr. Srinu Ji, Assistant Professor and Assistant HOD Department of Cybersecurity, MITS Kochi, for her enlightening and thought-provoking presentation. Your expertise, clarity, and real-world perspectives have greatly enriched our understanding and have truly added immense value to this session. Thank you, ma'am, for sharing your time and knowledge with us. I extend my sincere thanks to AICTE Training and Learning Academy for sponsoring this FDP. A special word of appreciation to Majlis Arts and Science College Autonomous for organizing this FDP in such a well-structured and impactful manner. I also express my gratitude to Dr. Vipina, Head of the Department of Microbiology, for the warm and gracious welcome, Ms. Akhila P., Assistant Professor, Department of Computer Science, for efficiently carrying out the role of rapporteur, and Ms. Chitra PC, Assistant Professor, Department of Computer Science, for her dedicated technical support throughout the session. Your contributions ensured that everything proceeded smoothly and professionally. Finally, a big thank you to all the participants for your active involvement and enthusiastic participation. Once again, thank you all for making today's session a memorable and enriching experience. Had a